Hey everyone, I'm back with another problem on the InterviewBit series for the topic arrays. So the problem today is perfect peak of array. So you are given an integer array A of size n. You need to check whether there exists an element which is strictly greater than all the elements on its left and strictly smaller than all the elements on its right. Okay. So we need an element which is something like this. So if I try to plot it up, so this should be the element, right? So this should be my element. It is greater than all the elements on its left and it is less than all the elements on its right. So it is also called as a peak. Okay, so if it exists, you need to return a 1, otherwise return a 0. Okay, and do not consider the corner elements as an answer, of course, and these are the problem constraints. So at least the length is 3 and can range up to 10 to the power 5. Okay, so now let's look at one test case. So we have 514, 368, 10, 7, 9. Right, so you need to find an index I such that it is greater than all the elements on its left, okay, and it is smaller than all the elements on its right. Okay, so this element would be greater than all the elements on its left and smaller than all the elements on its right. Okay, so how do you figure this out? So what is the approach? So one approach is I'll assume peak for every element and I'll traverse or I'll apply another loop. Let's take I here, right? So if I consider or I assume this to be my peak, so all the elements up till here, this current element should be greater than all the elements on its left and it should be smaller than all the elements on its right. So one approach could be I'll iterate through all the elements. Okay, so it would be something like I'll iterate for all the elements and then I'll have another loop, okay, which starts from 0. Let's say j is equals to 0 and it will go till I, and I'll check here for the maximum. Okay, and if the maximum of this part I'll figure out, and if this current element is greater than the maximum of this part, that means it is greater than every element on its left since it is greater than the maximum. Similarly, what I can do is I'll have another loop. It would start from I plus 1, will go till the end. I'll try to find out the minimum. Okay, and if I can figure out the minimum from here, and if I'll check if my current element is smaller than the minimum of all the elements on its right, then it would mean that it is smaller than all the elements on its right. So here I need to figure out the maximum, and here I need to figure out the minimum, and I need to do it for every element. Okay, so what would be the time complexity for this solution? So one loop we are having for iterating over all the elements, and another to check all its left, and another to check all its right. So it becomes O of n square. So can we optimize it? Can we do any better? So one thing which I can notice here is I can see a pattern here, right? So I need to figure out the maximum of the left half and the right half. So I can have some sort of prefix suffix if that would help. Yeah, that would definitely help because this is continuous. First of all, it is continuous. So the idea of prefix hits suddenly, and it is continuous in the left as well as in the right. So the idea of prefix and suffix comes to the mind, right? Okay, let's look at the prefix and suffix solution. What I can do is I can, at every index, I can maintain what is the prefix max. Okay, so I can make a prefix max for every element. Okay, so here what I need to do is, let's say I have a 5. So the prefix max is 5. So 5 again. And what's the maximum of 4 and 5? 5 again, 5 again. So now there is 6. So the prefix max becomes 6. Here it becomes 8, 10, 10, and 10. So I calculated the prefix max for this array. What does prefix max means? The maximum starting from the left continuous till that index I. What is the maximum element which you got? Right. Similarly, I need to figure out the suffix min. Right. Suffix min. And how will I do that? I'll start from the back since it's a suffix. And I'll try to take the minimum. So what's the minimum here? It becomes 7. And 7 10 7, 7 8 7, 7 6 6, 6 and 3 3, 4 3, still 3, 1 3, 1, 1 5 1. So now we have created the prefix max and the suffix min. So of course, now what I can do is I can iterate from the first element. Since we need to ignore the corner elements, I need to iterate only from this guy. It starts from this and which will go until this, right? Okay, so let's start with 1. What I need to check is what is the prefix max of 1. So one thing to note here is we won't take until this index. We'll take until I minus 1. So we just need to check if AI is greater than prefix max of I minus 1, then one condition is satisfied. Then one condition is satisfied. Right? Why I minus 1? Because prefix max till I also considers that current element. So prefix max at I will also consider 1 here. So we'll take 1 I minus 1. Okay. Similarly, the next condition would be AI should be smaller than suffix min of I plus 1. Again, why I plus 1? Because I would also include that current element which we do not want, right? We want after it on the right of it. So these are two conditions which you need to check, right? So which element satisfies both? If you look at, if you take a closer look at, let's iterate fully. So for 4, it is not greater than 5. We'll move forward. 3 is not greater than 5. Move forward. 6. For 6, 6 is greater than 5. Okay. And 6 is also less than 7. So it satisfies both the condition. So we have found 6 to be our answer. Since the first condition for 6 would be 6 is greater than 5 and second would be 6 is less than 7. So it satisfies both the condition. Right. So this is a perfect peak and we return a 1 for this. So this was one approach. What's the time complexity for this solution? It's O of n. Right. And what is the space complexity? Again, it's O of n. But can we optimize it one step ahead? Yeah, we can actually optimize it one further step. So the space complexity currently here is 2n, right? O of n for the prefix and n for the suffix. So actually we can reduce it to O of n. It's still actually approximately O of n since 2 is a constant and 2n can be approximated as n. But if you want a efficient solution which uses just a single array, then we can only maintain either a suffix min or a prefix min. You can take any of those, and depending on whether whichever you take, you start iterating from the reverse direction. So for our case, let's just have suffix min right now, and let's just look at what am I trying to say. Okay, so let's have a prefix min while iterating. So let's have a prefix max, and to be 5, which would be a of 0, right? Which is a of 0. Now I'll start iterating from I is equals to 1, and again instead of having this array, I'll update prefix max at every step instead of maintaining an array beforehand, right? So I'll check at every step if my 1 is greater than 5 or not, and similarly 1, we already have the suffix min array, so I can check if 1 is less than 3 or not. Okay, so one condition is only satisfied here, so we'll move on. And while moving on, you will take the maximum of, so you can say prefix max would be maximum of prefix max, so you'll update it and a of I. At each step after checking, you can update the prefix max, right? So here it would become here it would be remaining 5. Okay, now you can continue, and at this point you'll have prefix max to be 5 again, and at this point it would satisfy 6 is greater than 5 and 6 is less than 7. Okay, so then we would have been getting our answer, right? So the idea was, instead of having two separate arrays, we can pre-calculate either the prefix max or the suffix min. So whatever you take, you can take any of them, and on the basis of that you can reverse the direction and just maintain a variable instead of the other array, right? Okay, so what is the time complexity for this? It is O of n. What's the space complexity? O of n again. So it's just a single array this time. Okay, so this was the efficient solution for this. Okay, now let's move on to the coding part. Okay, let's code it up real quick. So we are given this array. First we can get the size of the array, which will be a dot size, and let's maintain a array which is suffix min, and we'll assign suffix min of the last element to be that last element only, right? Now we can iterate from the back, starting from the last second element. We'll go up till all the way till I greater than equal to 0, and we'll mark suffix min at I would be equal to minimum of suffix min at I plus 1 and the current element, right? Great. Now let's have a prefix max. It's not an array, it's a variable, right? Instead of an array, we can just maintain a variable and update it accordingly as we traverse. So let's just assign it to a of 0 for now, and we'll start iterating from first index, and we'll go up till the last second, right? I plus plus, and at every point you need to check if a of I is greater than prefix max. So currently prefix max always looks at whatever is at the left of the current element. It won't include the current element, right? Okay, and a of I should also be less than suffix min of I plus 1. Okay, so if at any point it satisfies the condition, then you return a 1. Okay, after checking, you can update the prefix max to be the maximum of prefix max and a of I, right? And at the end, if we do not find an answer, then you can return a 0. Let's run it. So the trivial cases are passed. We'll submit it. Okay, so it is accepted. So this was it for the solution. I hope you guys understood the solution. I'll meet you guys in the next video. Till then, take care. Okay, chalo, bye.